Time magazine called him the unsung hero behind the internet. CNN called him a father of the internet. President Bill Clinton called him one of the great minds of the information age. He has been voted history's greatest scientist of African descent. He is Philip Emeagwali. He's coming to Trinidad and Tobago to launch the 2008 Kwame Ture lecture series on Sunday, June 8th at the JFK Auditorium, East in Augusta, 5 p.m. The Emancipation Support Committee invites you to come and hear this inspirational mind adjust the theme, crossing new frontiers to conquer today's challenges. This lecture is one you cannot afford to miss. Admission is free, so be there on Sunday, June 8th, 5 p.m. at the JFK Auditorium, East in Augusta.
It takes 8 minutes to describe how I mapped 8 initial boundary value problems of modern calculus and computational physics and mapped them onto 8 processors that were a subset of the 64 binary thousand processors that I visualized as evenly distributed across a small copy of the internet that enshrouded a small globe. At that rate of 8 minutes for 8 processors, it will take me 10,000 lectures to describe how I experimentally mapped 2 to the power 16 processors across a new internet that's a global network of 65,536 processors. Looking back from June 20, 1974 in Corvallis, Oregon, United States, my lone search for what makes computers faster and for what makes supercomputers fastest was like going into the Sambisa forest of northern Nigeria alone and in search for the elusive Chibok girls that were held hostage by Boko Haram fighters. Parallel processing was the holy grail and the Chibok girls of supercomputing. Searching for the fastest parallel processing supercomputer was like walking at night and along an uncharted road in the Sambisa forest of northern Nigeria, and doing so armed against Boko Haram fighters with only a small lantern. As we struggle to solve the grand challenges of massively parallel processing supercomputing, we reveal more grand challenges such as quantum computing. On the 4th of July of 1989, I experimentally discovered parallel processing, and therefore nobody else can experimentally discover parallel processing again. What was overlooked in the news headlines was that my world record speed of 3.1 billion calculations per second in 1989 was verified by the Computer Society of the IEEE, the largest society of computer professionals. My world's fastest calculation was verified as evenly spread across 65,536 commodity processors or CPUs, with each CPU contributing 47,303 calculations per second. The 4th of July of 1989, the US Independence Day, was the day I experimentally discovered the world's fastest computation and discovered it across a massively parallel processing supercomputer that is the precursor to the modern supercomputer of today that hopefully will become the computer of tomorrow. There are 3 methods that I could use to decompose the oil field that my petroleum reservoir simulation represented to experimentally discover the fastest computation across my ensemble of processors demanded that I achieve a one-to-one nearest neighbor mapping of my 64 binary thousand initial boundary value problems to my as many commodity processors. In my first method, called slab decomposition, I divided my three-dimensional oil field into 65,536 one-dimensional slabs or oil blocks. In my second method, called pencil decomposition, I divided my three-dimensional oil field into 65,536 two-dimensional pencils or oil blocks. In my third method, called block decomposition, I divided my three-dimensional oil field into 65,536 three-dimensional oil blocks. This analogy represents what we knew about parallel processing during the early 1970s. What I believed in the 1970s was that my email must travel across 65,530 processors to be delivered to a processor that's 5 processors apart. My 1970s thinking was that if I try to send and receive 65,536 emails at once, that I will fail in sending them all. And as I intellectually matured as a research mathematician and as a research supercomputer scientist, I discovered that a computer screen comprising of 256 by 256 pixels or 65,536 cells can be coded with circularity. In layperson's terms, circularity means that the lower edge of the screen touches the upper edge of the screen. That circularity occurs when the right side of the screen touches the left side of the screen. I coded circularity into my email messaging in the 16th dimension, not in the 2 dimensions that I described. But I applied the same concept of circularity in the 16th dimension, and I did so in part to enable me to record previously unrecorded speeds in floating point arithmetical calculations. That circularity was in the granite core of my world's fastest calculation that was heard around the world. My experimental discovery of massively parallel processing was the news headlines because I recorded the world's fastest calculation, and I recorded it by solving 65,536 problems at once. That experimental discovery of a new supercomputer made the news headlines in 1989, and it was recorded in the June 20, 1990 issue of the Wall Street Journal, and was in the June 27, 1990 issue of the Chronicle of Higher Education, the publication that distributes news to universities.
Insightful and brilliant lecture.